Welcome back. Today we'll be looking into cache invalidation. In my last video, I have explained and implemented how caching works in .NET Core and .NET 5. But after the implementation, we came about a problem, which is, what if something changed at the back end and then we need to synchronize it with what we have in the cache? I mean, if we have a data in the back end and we have a data in the cache, and if I change something from the back end and user is trying to get data from the cache memory, that means the user is getting an outdated data, right? So there's a problem. We need to come up with a system that can sync any update from the back end file to the cache whenever there is a change in the back end file. So it has to sync with the cache. And the best way to solve this issue is to ensure that we have a syncing mechanism within the backend data and the cache data. That way, if anything changes from the backend data, it will actually sync with what you have in the cache data, and user can keep getting the same data at faster rates and ensuring data integrity as well. So today we'll be looking into cache invalidation, and there are several ways we can do cache invalidation. So today I'll be using the file system. The database system is actually pretty easy. There are several systems we have walked through and a whole lot of them, but I'll be using the file system, which is one of the most complex cache invalidation. So we'll look into it today and see how that works. Follow me, and please don't forget to like this video and subscribe. This is our application from the last time, and if you notice, when I execute the test key, so it's actually coming from the cache, looking through the debugger. So it's checking the cache, the value is available in the cache, and then deserialize it and return it for the user's view. There we go. So now there's an issue here actually. So if we go to this file source, which is the text file that we are reading from, what if I go ahead and change something here? If I type something like value change. So I've changed the value in this file now, right? And I've saved it. Now the user is supposed to get that new value, but if I go ahead and still request the key is still getting the old value from the cache, because there is no link between the cache and the file itself. You can see it's still getting the old value, but the value in the file has changed. But this value is what we have stored in the cache, so we are still getting the old value. So now this system is still vulnerable to data disintegrity, but we need to make sure there is data integrity. When I say data integrity, I mean we are getting the real value from the back end to the front end, even though we are using the cache as a intermediate memory storage. So we need to create a file invalidation system that can actually ensure that whenever we make any changes from this file, it will automatically sync with the value in the cache and then update the cache. That way the user will still be getting the same value, right? So let's see how that works. That process is actually called cache invalidation. I'm gonna go ahead and close this page. And first thing I'll do is the cache project, I would create a folder here, add folder. I'll call that my files. So this folder, I want to monitor anything that happens in this folder. So I'm going to drag this text file into this folder because I want to be monitoring it, right? So whenever there is any change in there, I want it to actually update the cache. So now we have this folder. Now how do I monitor the folder? In Microsoft, we have a library in Microsoft, which is the file system watcher. I'm going to go ahead and create a class now. this file system watcher is watching this folder path. So if anything changed there, I want it to tell me. Now, how will I tell it to tell me? I'm going to go ahead and give it instruction. Take, for example, if I hire a security guard in front of my house, and I'm telling the security guard, just watch the gate, right? Now, the security guard will listen to that instruction. Now, I still need to train the security guard on what to do when event happens. Like maybe if somebody knocks on the gate, ask the person, who are you? Verify the person. What if the person tried to boggle into the gate, right? Then I can instruct the security guard to be aggressive in handling the situation, right? So we can actually instruct it, but for now, what I'm only doing is telling the file system watcher, hey, just watch this folder. So I need to go ahead and instruct it also, you know, what to do when changes occurs. So how do I go about that? I'm going to go ahead and create a method. I'll call that public void. I mean, I'm not trying to have it return anything, I'm just telling it do this, so I can use a void in that. I'll call that instruction, just for example. In the instruction, I'll have to use this object to call the inbuilt method there. So I'm saying file system watcher dot changed. When anything changed there, I want you to actually call this method invalidate. So I will need to write out that method. We'll get back to that. I need to write this method, but I'm saying that if anything changed there, just call this method. So in this method is where I'll actually, you know, update the cache. But there are many things we can do with this file system watcher also. So if I call the object also, so file system watcher dot enable raise event. So enable raise event means you should trigger this invalidate event when you notice an event occurred in the file that we are watching, right? I'll set that to true. And last write, last access. There are many things here, but I'm not going to go deep into the file system watcher. You can actually, you know, tell it to check if there are even sub folders directory, right? If there's a folder in a folder, monitor everything. But for now, we don't need that. I think I also like to have it select a notifier. Notifier filter is like, okay, when something changed there, what kind of change did we observe there? Let's see what kind of change we have. Notifier filters dot last write. Well, in the last write, if anything changed from the last content we have in the file, yes, raise the event. We can also change that to, let me see what other ones we have there. Notifier filters dot last access. Okay, I think I'll just use these two for now, so we don't get too consumed in this. And we have that. So now
Oh.
So the way to do that is this dot cache key, or I'll just put an underscore there. I like my code clean and clear. Equal to cache key. So now what I've done here is, by the time I call this constructor from outside of this class, I can supply the key there, and then the key will go ahead and map it with the invalidation. So moving forward, what I'll do here is distributed cache, the object here, this cache object here, the distributed cache is an asynchronous. They are all asynchronous methods, so I'll have to add async here. So then here I'll call await cache dot set async. Now I want to set the new value of the cache there. So how to do that is to add the key, and that's a cache key. Then how do I get the new object, right? The new file, right? So what I have to do is I have to read the content of the file. File content equal to system.io.file.read all text. So how do I get access to the file? The way to get access to the file is to actually use the this object here. It will give me access to the file, so which is e.fullFilePath. So because this method is actually monitoring the whole folder, so any file that changes there, this event argument is keeping track of it. So it's giving me the full path. So I'm reading the file content, and I'll serialize it. Serialize file content, right? JSON convert. Let me import that real quick. Control period. Okay. JSON convert dot serialize object. And I'll put this file content there, which has been serialized. Then this serialized file content is what I'll supply here, and that's it. But one more thing, the set async is expecting a binary array, byte array, so I'll have to encode that. Encoding .utf8. Let me import this real quick. Text dot get byte. So I'll supply what the set async wants, and I think pretty much that's it. So the invalidate is going to read the file part again, serialize it, and set it to the cache. So by the time the user calls the next key, we'll get the latest value in the cache. So now how do we use all this? The instruction here, we have to register it in the controller and call the invalidate method. In real life application, I'll register that in my startup class. That way, the moment we launch the application, these files will be automatically being monitored. But just to save more time, I'll just put that here in the controller. So now this is our controller. I'm calling the get method. But before the get method start, running, I want to register everything we've done here. In the invalidator class itself. So what I'm going to do is I'm going to instantiate the invalidator class in the first controller here. So just to quickly get that off, let me call that public invalidator. I'll just instantiate it direct. Invalidator. Okay, I'll leave that at that. Then I could even go ahead and set it in the method here. So the invalidator is equals to new invalidator class. Now the invalidator class is going to ask for two parameters, which is the distributed cache object and the cache key. So of course I'm going to put our distributed cache object here, and then the key, we're supplying the key there. So that's that. Now with this I can actually use this to call the methods in there. Then what I'll do next is invalidator dot instructions 1, then invalidator dot invalidates. So I don't even need to call the invalidate at all, because in the instruction itself, if we go to the instruction itself, go to definition. So the moment this instruction is already monitoring all this, when this event happen, when something changes, it will trigger this one. So we don't even need to call it there. So that's all we need to do. That's all. So let's try it one more time. I'm going to go ahead and run the application. Execute that, continue. So now I'm getting this aliens, Jibril says hello from planet Earth. Now if I go back into the file folder, my file, and I open up the file, so if I make a change here, maybe I delete everything here, or I just say Jibril says hello and just add all these random figures there. The moment I click save, so let me put a debugger here in the invalidate method. So the moment I click save here, it should trigger the invalidate. Save. You can see that's triggered the invalidator because that folder is being monitored. So now if I run it, the file contents, we have the new, we have the new value in the file contents. So automatically all this will be happening behind the scenes. It will update the cache, serialize it, and then push it into the cache. Let's see, what do we have here? Not set to an instance of an object. So the reason we are having that error is because it should be a dependency injection issue. So I think this part, I'm supposed to inject it in the constructor. I'm going to go ahead and inject it. I'll stop the application and I'll inject it here. Go to cache, and that should resolve the issue. So we are going to go ahead and run it again. Okay, there we go. I'll try it again. Test key, execute it, and that should give us the value we have in the cache, right? Jibril says hello from planet Earth, right? So if I go ahead and change something here, Jibril says hello from planet Earth, and I put something like value as changed, right? Then if I click save here, it will trigger the invalidator. So there we go, it triggers it because the file is being monitored. Now if you look at this object here, the object is pointing to the file that is being monitored. You can see that there. So we are going to go ahead and go in there, read the new content of the file. So we can see the new content of the file, value has changed. I'll close that, and then serialize the value, set it into cache, and that's all. So all this will happen behind the scene. By the time the user calls the key again, executes, the user will get it from the cache. So you can see the value is coming from the cache, and it will be the new value. So if you look at it, it will be the new value. The value has changed. So this is coming from the cache and it's getting the new value. And if you go to the back end again to change something, then maybe we write random figures there, 21111, we save it, and it will come up from the cache with a new value. So that's pretty much how that works. And if I go here and call the key again, so I'll go ahead and continue that here, and then it should give us the value. Okay. Continue. So there we have it. And the beauty of it is test key. If I go and run another server, maybe like the test server 2, I can still call the key and I'll get the value from the cache, from the set as startup projects. Yeah, the new value from the cache. So if I come here, these two projects, I'll run them together. Properties, run multiple projects. I'm running both projects together, and I'll call the same key. Okay, so these are our two servers coming up. So if I go ahead and run the test key from server 1, I'll be getting the value from server 1. So server 1 is giving me the current value, and if I try to call it from server 2 as well, which is test key, so server 2 should also give me the same value. So this is it from server 2, same value. So if I go to that same file and change everything there, or make the changes there, I remove all these 2.1 and put it back to from here, and I save it, it will trigger the invalidator. Save, trigger the invalidator. The invalidator will do its thing behind the scene. So if I call any of the servers, either server 1 or server 2, with the test key, execute test key. So the execute test key will actually give us the new value there, which is you can see the new value. And if I call the second server as well, I'll execute the test key, so we should be having the new value there. So that's how cache invalidator works. So the moment anything changes from the file, it will update the cache memory, and then the user will still be getting the real-time data at a faster pace. So pretty much that's how cache invalidator works, especially for a file monitoring system. We can also do it in database system as well, using a different approach. So there's different ways to do it. So feel free to put a comment down if you like this video or you feel it's helpful. Don't forget to smash the subscribe button and share the video. Thank you.